Okay. So, Assalamualaikum warahmatullahi wabarakatuh. Good day,
Waalaikumsalam.
good afternoon, everybody. Selamat sore, selamat siang semuanya. So, welcome again in the sixth lecture from Professor Mark Russell from the School of Construction Management, University of Florida. Today, we are going to talk about green building performance in the USA, right? Green building development in the USA, while I think you will also talk about the LED, right? The LED. Okay, so
LEED,
Professor Mark,
yes.
please
Lead. Okay.
lead.
Oh,
Yes.
so, well, thank you very much, Bu Ova and Pataga. And I've greatly enjoyed doing this lecture series. I hope that you found it informative and my English isn't too hard to follow. So let me go ahead and share my screen. All right. Did everybody see my opening screen? Excellent. Thank you. So mainly I'm going to talk about LEED, the LEED rating system, and just kind of give some overview of how that works. It's very similar, I know, to Green Ship that you have in Indonesia. We'll talk slightly about how to get certified a little bit towards the end of that. So, all right, so overall schedule, we're on the last of the lectures. So main topics today is USA Green Building Rating Systems, a overview of LEED. I'm going to talk about LEED material credits, the credits that they specifically address relative to material selection, which have a large impact on. A little bit about accreditation. So this is kind of a brief map showing different rating systems that are used throughout the world for buildings. Different countries have different cultures. Different cultures value different things, different elements in their buildings in different ways. And so as a result of that, we end up with a variety of different building rating systems. And in the US, our primary rating system, our LEED is probably the most popular. And then Green Globes is the one that I do a lot of work with. It came out of Canada and has come into the US also. So are both very popular. So the LEED rating tool has gone throughout a lot of the rest of the world and has been adapted into other similar programs. So I know the Green Build Council of Indonesia has developed the Green Ship is the local rating program, and I'm curious of your experiences of working with them later on. We'll discuss that. So rating systems are a valuable tool to provide that third-party assessment that yes, you are doing something sustainable. It carries a lot more weight when you can get somebody else to say it as opposed to saying it yourself. So good to have this third party provide that validation. So in the US, the people that monitor most of our buildings is a group called GSA, General Services Administration. And they are always assessing to determine which rating tool they want to use on US government projects. And the two that they have recently approved are LEED and Green Globes. And I just want to do a little brief analysis of the difference between the two. And both rating systems pretty much look at the same things. They just kind of do it in different ways. And so LEED is run by the U.S. Green Building Council, and it is strictly online. All your forms are uploaded online. It gets sent off to this black box, you might say, and then the people at USGBC take that information, send it out to member companies, committees. They evaluate it, and they come back and tell you what, yes or no, these type of things. And so the Green Globes, they assign an assessor to you, and I've assessed several hundred buildings for Green Globes, so I have a lot of experience working with Green Globes. And as an assessor, I work with them to evaluate the data specifically, so they know who's evaluating it. They have one person to ask for any questions. Then when the project is complete, I used to actually go to the project and walk it and physically see, yes, they did what they were supposed to. And recently I haven't been able to do that for obvious reasons. I did an assessment actually on Wednesday in Las Vegas for a nice hotel complex. And we do it all virtually now. And to be honest, I don't like doing the virtual as much. I would imagine most of you have visited, sustainable buildings, and you normally get a feel pretty fast when you've done a lot of buildings. Within a matter of minutes of walking inside, you can tell. Have they been, if you got that new car smell, then you know they haven't done the right thing with the DOCs. If you don't have nice daylighting coming in, if you don't have, if you can't see that quality built into the project, then you tend to wonder. It's almost like getting into a old beat up piece of car as opposed to getting into a nice quality, well built type facility. And so you can tell pretty much as soon as you walk in whether or not they've done the right stuff. And so that's why I really enjoy the third party assessment. It brings in another set of eyes and to the project. So LEED has done a fantastic marketing job. They are the leader as far as the number of projects done in the U.S. Green Globes is growing dramatically. We've had a huge push on projects. In the last week, we've had a lot of big, as projects are trying to get certified prior to the election, so they can get really low interest rates. And so there's a company that looks after a lot of our mortgages, gives a lower discount rate for projects that are sustainable certified. And so it's a way that we try to, in the US, to try to encourage people to do sustainable ratings to try to make the building more sustainable. They give them a lower interest rate. And so so when you borrow the money for that, it makes it cheaper. And I think it's a wonderful program. LEED is based on 110 points, Green Globe's 1,000 points. Again, we look at kind of the same things. It's just how we weight them. And provided the websites for you. Strongly encouraged to go to those websites, get tremendous amount of information, a lot of good training materials available out there. And so recommend try to take advantage of that. Kind of an overview of LEED is the LEED has 5 main categories nowadays. And when you get accredited as a LEED professional, nowadays you select which one of these main areas you want to specialize in. And so quite often you'll see people as listed as LEED, AP, B, D, and C, right? You put all these names, letters behind your name. And what they're referring to is the LEED, accredited professional, and then what your specialty is. So the most popular that covers almost everything is B, D, and C, building design and construction. It's basically bringing big new construction projects or major renovation. The next one you'll often see is interior design and construction. And this is often in a like a shopping mall type environment, a place where the tenant is leasing out spaces from another major client. And the reason being, since the tenant normally doesn't have control over your mechanical system, they look at things a little bit different in this one. So this is usually the case before it's a tenant agreement as opposed to the owner directly owning the space. Operation and maintenance. This is usually for existing buildings, and you evaluate that yes, they have been, they are continuing to maintain them in a sustainable way. Neighborhood developments. I really like this credit. They Green Globes doesn't have a credit that says we're going to take this entire community and make it sustainable. And I think it's a wonderful idea, and I think it's very worthwhile to look at. And then LEED for homes. You can have your own home evaluated LEED also. So I think it's a great thing to really try to encourage the entire community and the people living in it. If you can, get your from where you live to where you work to where you shop, all these areas, try to evaluate them sustainable. So the main categories that LEED looks at. The first thing, it's a prerequisite, is they require that you have an integrated process that we talked about earlier, of how your team has to work together throughout the entire design and construction process. And they evaluate location, transportation to and from the site, material resources. We'll talk more detail on that one today. Water efficiency, energy efficiency, sustainable site, what you do to promote plant growth. Try to just, you don't want to have this big concrete jungle. You want to have well shaded, well vegetated areas. Indoor environment, things you try to do to promote a good, healthy atmosphere inside, good airflow, good lighting, acoustic comfort. And one of the things I really like about LEED is they promote innovation. And so if you do something new, find a new method to improve things, you can get credit for that. And another one that was recently added was regional priority. And so each region can pick things that they find most important to them. And I call this my extra credit, in that, so if you, let's say in Florida, one of our big concerns is energy and atmosphere. And so if I earn the particular credits that are most important in Florida in energy and atmosphere, then I can get this extra credit points also based upon the regional priority, saying this is even more important to us. You can get more credit that way. It's kind of a nice way to do that. The buildings get certified. Certified is the lowest level. All you need is 40 out of 110 points to get certified. Silver is kind of the standard for a lot of government buildings. Say is they want their project to be certified at least to silver standard, so it's kind of a little bit better. Gold is higher. Platinum is difficult. I've only worked on very few buildings that are platinum certified. I find at the University of Florida, for example, we require until about 4 years ago, we used to require all buildings to be silver certified. Then they found that you could get silver pretty easily. And so they've now, the University of Florida, we say all new construction must be gold certified. So we've upped the scale. So we're seeing a number of people doing similar things to try to push further to make the buildings more sustainable. LEED was formed back in 1993. First version of, U.S. Green Build Council, who runs LEED, was formed in 1993. The first version of LEED came out in 1998. They updated that. This is kind of the pilot version. So the first real marketable version was in 2000. And then every couple of years, they update it. So in 2007, they developed a kind of subset called GBCI, Green Building Certification Institute. And so LEED was originally developed as a not-for-profit organization. And so around the time of version 2, I got my LEED accreditation back about 2006, 2007 timeframe. So the program was starting to take off at that time. And they were getting a lot of funding from a number of sources. And they realized, we can't keep USGBC not-for-profit if we're getting these different fundings in. So GBCI is the group who monitors the certification, monitors the accreditation of individuals, and they have a lot of different training programs available for that. And they are the for-profit branch of USGBC. So they take care of all the financial aspects of that. LEED version 3 came out in 2009. In 2013, they came out with LEED version 4. And this is a unique one. LEED version 4 was really done a lot by sustainability experts, people that are really trying to push the bubble to make building a lot more sustainable. And so they really, each time we get a new version, they get the requirements more and more stringent, because we want to try to push industry to become more sustainable. And so LEED version 4 was an attempt to really push that envelope. And shortly after, they realized they had actually probably pushed it too far. Some of the requirements had criteria that a lot of portions of the country couldn't meet. And so it's like, well, maybe we need to rethink this. And so a lot of the industries were pushing back, saying, if you're going to make that the standard, we can't do it. We'll find something else. And so I don't know if you'd say unfortunately or fortunately, whatever the case, They came out with LEED version 4.1, in which they kind of ratcheted it back just a little bit to kind of balance more between what was on the what was available in the industry, and still LEED version 4.1 is still significantly more sustainable than the version 3 version, and but you know, it certainly is giving industry a signal of, all right, here's what you need to be doing. And so I thought it was very innovative of them. I thought it was a great way to you know, kind of educate on where we need to be going, and so now now they recognize, all right, let's take it in a reasonable step to implement that. So version 4.1, if you do any project, that's what you're going to end up using for it. So point structure for LEED is 6 categories: location, sustainable sites, energy and atmosphere, water. We've already talked about all of those. So LEED is really nice because it's got certain prerequisites. You have to meet these criteria in order to get your project certified. And it's things like you have to show energy savings, you have to show water savings, and so it's actually one of the things I really like about it. So as soon as you see that you've got a LEED stamp on a building, it means your energy savings is about 20%, your typical building resource. Water savings about 30% of anything else. So they also have minimum project requirements. This was a great idea in that when I first started reading the minimum project requirements, you have to start wondering, you know, what people were doing that they made USGBC all of a sudden realize they've got to document you can't do that, right? And so they had little things like the building had to have at least one person work or operate in the building. And it's like, really? People are trying to certify buildings that nobody worked in, right? You had to have a reasonable boundary for your building, okay? And they apparently they have like huge, you know, multi-kilometer sites, and people are putting one little small building in that and trying to get it certified. And so, so they have these basic minimum project requirements that say it's got to be a reasonable building and a reasonable lot, and people actually have to work in it. So anyway, so we're gonna focus mainly on the material resources credits. So this is just a part of the scorecard, and so when evaluating buildings prior to starting on the certification, I always recommend go through a scorecard and see how the project looks. And a scorecard is a great tool for doing the analysis. And I'm just going to briefly talk about how I do look at scorecards and what I recommend that you do with it. And so we're going to focus today on the material resource section, but just as an example, when you're doing the scorecard, you get your points for the entire section, right? So we have 6 sections that we're looking at. First column is yes. The end column is no, right? So yes, we're going to be able to achieve those points. No, we're not going to be able to achieve those points. The middle column I call is my question points. And question points are an almost 90% of the time, question points are if the owner had additional funds, we could do this particular criteria. And so so when you're first evaluating the project, what you do is you fill in all the yeses. Yes, we're going to do that. Yes, we definitely, you know, we're going to manage all our construction waste. We're going to be able to do all that, right? And the other ones you go through and look at all your no's, and then whatever's left are your question marks. And so I always recommend, once you know what your yeses are and your no's, take all the question marks and assign a dollar value to them, right? All your ones that are unknown. And so, for example, originally I wasn't planning on doing water metering. I could do additional water metering if the owner had extra money. Well, how much extra money would it cost? And so you put a dollar value to each of those question mark items, and then you pull those out. And I do a typical Excel spreadsheet, and you do the questioned area, the dollar value, and then a cumulative cost at the end, right? And so then I sort them all by the dollar value of the item, such that you get the lowest dollar value items at the top, right, all the way to the highest dollar value items, and then cumulative. And it becomes a very handy tool for presenting to the owner. You can sit there and say, all right, if you had an additional, $10,000, you could go on the side of the cumulative and say, we could do all of these additional items. Or if you have any particular ones, things that you like, right, that we could go above and beyond, you can pick those out also and move them around. And so it's a real handy tool for helping to determine how you can go above and beyond what you were typically just plan to do, right? It gives the owner that idea of the cost for it. And so the thing I recommend is be cautious and that try to get a feel for your owner as far as, if there's any priority areas that they want to focus on. So that you may need to bring out otherwise. So it's a very handy tool for that. All right. So resource, we're going to go through this one pretty quick. So even though there's lots of areas within the building design and construction, we have new construction. This is core and shell. This is the main core of the building. Schools have their own criteria. Retail facilities, basic stores. Hospitality, this is like hotels. Healthcare, hospitals have their own area. Data control centers, because they have such different air conditioning requirements, they break out separately, right? And these are warehouses, right? Also have their own criteria. So we're mainly going to be looking at new construction. I'm not going to, if you're working on any of those other projects, recognize they have their own individual criteria also. So prerequisites is you have to collect recyclables. Any facility that's getting LEED has to meet this minimum. It has to have some designated area for dealing with recyclable material. So they recognize that up front. And so they know that if you have that assigned, it makes the process easier. The next one is you have to have a plan in place of how you're going to handle your construction waste. So naturally, all construction projects are going to have some waste. It's a plan, right? So what you're going to do with it. In the actual credit areas, the first main credit is doing a life cycle impact reduction. We were talking last class about Athena, the eco calculator. And so you're going to run this program and compare your building to a base building and show the savings you have for that. So there are actual criteria that say how much of a savings you need to get points. But by running that, you can get raise points for that also. Next credit is environmental product declarations. And so if a certain percentage of your material has gone through the certification process for EPDs, and when you actually go into the credit itself, the details of it will spell out what performance EPDs they need to be above the standard. I'm not going to go into the details on that now, but so for certain many of your products have been certified by a third party for environmental product declarations, get that point also. Next credit is for raw materials. And so if a certain percentage of your raw materials have gone through a certification process, and the one that is most popular, at least in the US, is FSC. It stands for Forest Stewardship Council. And the idea is that your forest has been sustainably managed. It tries to encourage wildlife to wander through there. It doesn't just come in and clear cut the entire site. It tries to maintain a nice, healthy environment. And you have this regulated method of how you're going to grow new and replace the old, and it's a wonderful process. So if your raw material source has been gone through a certification process like that for a certain percent of products, you get points for that also. A similar one is the credit for material ingredients. And so there's a group called CAS, American Chemical Society, and they will evaluate products and look at what chemicals are involved in it and determine that it's done in a sustainable manner, that you're not just releasing your pollutants out to the atmosphere as you manufacture the product, that it's, they look at all the chemicals involved and the whole processing side of it. And so a little different than EPDs, because this is more a straight chemical analysis as opposed to the EPDs being more of a life cycle type analysis. So, and Next credit is demolition waste. And the idea is that you divert your construction waste into some other place. You reuse it, recycle it, something other than just running it to the landfill. And so for a certain percentage of your waste is diverted, you get credits for that. And then indoor environment quality, there are ones in this group that also directly relate to your material selection. Right? So environmental quality deals with things like the acoustic performance, how well sound monitoring is, your lighting, your thermal comfort. But I want to focus on the low emitting materials, your low VOCs. So again, your material selection is going to pick things specifically that have don't off gas large amounts of carcinogens. And so by selecting low VOC products, you earn credits in this area also. It's just kind of unique that your VOC credit is not part of the materials one, right? Even though it's material selection one, it's actually part of the indoor environment one. So, all right. Those are your main credits that deal directly with materials. It accounts for about 13% of your overall credits. So you have a major impact on the sustainable rating that your building gets by selecting appropriate materials. So as an architect, you have a big impact there. Accreditation. In Indonesia, you've got Green Chip and their accreditation program. And I put the website up here. How many of you out there are Green Chip cert accredited? Is anybody?
We have some also, Prof, in our class as well.
Oh, fantastic. Now, are they Green Chip associate or Green Chip professional, right?
Normally, as we are in the university, we stop at the GA.
Yep. Okay.
Associates, but for the professional one, they are going through to the professional GP.
I was, fortunate all of you can read this one. There's when you go to this website, if you go down further, there's one I can read. And so I am very impressed with your Green Chip program, in that it requires that you have at least, for the associate, you have to have at least a high school or equivalent certification. To be a professional, you have to have a college certification. You have to go through a certain amount of training. Very impressive. When you look at LEED, we have our main LEED Green Associate, and then you specialize in your individual areas. Very few people ever get to the LEED Fellow, but we don't have minimum education requirement at all, right? As long as you pass the test, right, you get the certification. We do say that we would like for you to have, if you go for your LEED professional, we'd like for you to have experience working on a LEED project. But there's no, it's not a set requirement, right? So experience working on a LEED registered project is strongly recommended. Right? I hate to say, but what does that mean, right? If I have no experience, they're not going to take my money and let me take the test. And so, but now, granted, if I haven't, I'll be honest, because of being a LEED AP, if I had not worked on projects, it's really difficult to get certified if you don't have the experience. But I think the way that Indonesia has addressed it is far more professional. I really respect the way they've done that. And so the cost is actually very similar. I looked up the Indonesian cost relative to the US certification cost, and it's not cheap. So, but so it's very, very, very similar on my side. Does Indonesia, do you have continuing education units? Do you have to take so many continuing education courses to maintain your certification?
Yes, we have also some credits from webinars, from workshop, for example. We earn.
Yep. So the US. So when I first got LEED accredited back in 2006, back then there was one test, and that was it. Your LEED AP, that was all. All right, and there were no CEUs. I'm a LEED AP for the rest of my life. Then all of a sudden they came out with the method of you need to do CEUs, you need specialties. And I kept getting all these constant emails saying, oh, you should come over to the new system, right? And I knew as soon as I went over the new system, now I'd have to do the CEUs, I've got to pay the annual fees, I've got to do these type of things. But because I'm grandfathered under the old system, it's like, I don't think I want to come to the new system. So I'm still just a regular LEED AP. I'm not a specialty one. But I don't have to pay any fees. I don't take any CEUs, and so I don't have to worry about those type of things with it. So, if they were to consider my engineering CEUs, I would do it, but they won't. They want to take their own.
But actually, how much different between the if you didn't update the AP, for example?
So the issue would be if I was to work on a project, you can get a 1 point for having a LEED AP specialty person on your project. And so, you know, if I was to work on a big project and I'm they couldn't use my LEED AP as the thing to get them the 1 point. So, but all the projects I've worked on, we usually have a team of people. We have multiple people that have LEED AP that they can use for the 1 point for that. So it has never been a problem for me. Right? To be honest, most of the work I do is now Green Globes anyway, and so so I encourage you to look at that. And I think hopefully I haven't gone over on my time too much. So,
It's okay. It's okay. I'm still curious also, maybe from our students, we still have questions regarding your presentation. Could we have like one or two questions?
of course.
Yeah.
Yeah.
Okay, please, Natasha. Professor Mark, can you? Yeah. Okay. Thank you. Please, Natasha.
Thank you for the presentation, Prof. I want to ask, to conclude, the LEED is more focused on the user criteria and specific bioregion based on the building itself. Meanwhile, as far as I know, the WELL uses medical and related data that explores the connection between buildings as well as the people who work at. Thus, may I know what is the implementation between LEED and WELL in real cases? Is it possible to be combined or not?
Is it possible to do both, LEED and WELL? Is that
Yeah.
the question? Oh yes, definitely. And so, and they you know, if possible, they recognize, you know, they recommend doing both type systems. And so yeah, as far as I know, I don't think there's any limitation that says you can only do one and not the other. So, yeah. So I have not done any WELL buildings, to be honest with you. WELL or EDGE or Living Building Challenge, or I think they started out just a few years ago. Fantastic programs. Like you said, they really focus more on healthcare type aspects. So it really looks at that clean environment. I've heard that WELL has really been taken off recently because of the COVID issues. People, you know, see that it looks more for that healthy, clean environment. And so, but, sorry.
Okay. Thank you, Natasha.
Mhm.
Any
Yes.
other questions? No, Professor Mark, I have also my own question actually.
Okay.
Regarding the LEED version 4 that you mentioned released in 2013.
Mhm.
And again in 2018, it is another revision LEED
Mhm.
revision
Yes.
for the, I was wondering what are the main constraints actually? You mentioned about some difficulties that the industries couldn't reach it.
Mhm.
But I mean, within these 5 years, what is actually the main constraint?
And so some of the requirements they had for the HVAC systems, for the mechanical systems, were very challenging to attain that level of efficiency rating. There was only a few companies out there that had equipment that was that highly sustainable, and so it was almost like saying, we want the only way you're going to get certification is if all your cars are Porsches. Right, and so you know, Porsche naturally is very expensive. It's a, you know, very limited thing, and so as you might imagine, all the other car industry is like, now wait a minute, right? That's not really fair to us. And in addition, the owners were all like, well, that's not really fair to us either. And so you know, from a sustainability standpoint, it was great in that it had that higher level, but at the same time, it wasn't really fair to the industry to expect them to ramp up everybody to ramp up to that same level, in, in such a short amount of time. So they kind of brought it back to a little bit more reasonable, saying, okay, we want everybody to at least have, a high quality level, and so, and recognize that this is the direction we're going. So, yeah. As far as specific example of changes, I'd need to go through my research to give you a specific one. If you go actually to the USGBC website, they have a section where it talks about the difference between version 4 and version 4.1 and what was changed about those. So.
Okay, thank you, Prof. Mark. I don't know, because in my opinion, still the certification itself, the more higher you got for the rank, it means the higher the rank for the for the room space. Okay, then shall we start the presentations? Yeah.
Yep.
Okay. So again today, Prof. Mark, we will have the group presentations from our students. It is divided into 3 groups. The main concerns is actually about the constructions and materials that they were brought in the presentation. But then we will start from group 3, yeah, and then continue to group 1 and then group 2. Yeah, we will just mix it up like that. But I'm really looking forward for your grade, actually, Prof. Mark. Yeah, we can be sure that I think in this time, me, Patoga, and you will give a grade. Yeah, and the range is from A until I don't know. I don't think you will give D or C. Yeah, but let's give it like A, B, and then we have A minus and B plus in between. Okay. So, group 3, are you ready?
Yes, I'm ready. Thank you.
Okay, then we will start to have the presentation from group 3, please.
Okay, let me share my screen with. Okay, anybody can see it? Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, Mr. Prof. Mark, and then good afternoon for all of us. I'm Reski Nugara. I will presenting about the theory or idea that my group been make of this presentation. What we want to talk is about a reuse building material to make a new building. As we know that nowadays construction been growing so fast, so many fast moving material that been used regularly either for new construction nor for renovation project. Then usually a customer in field, they only want to have a, let me say, less difficulty to make their own building. So they usually only, they always say, buy new door, buy new window, and etc. They never think about old material they have been before. This habit will lead us to, that short-term effect of a consumptive habit that will lead us to have a huge waste in the field, or we have improper waste and good management. For this problem, we can use reuse method. This method we're reusing old material that been used before. This method we reduce waste, eliminate production energy, reduce carbon footprint, and also economic value for community. With this concept, we can collaborate it with modern architecture that using manufactured material and component that has manufactured set and quality. So if we have a good method to do demolition, we will get so many results that we can use again in modern component. Single material as well as assembled material. As we see from the cycles below, if we have a grid plan, that plan is talking about how it maintained and how it demolished, we can reuse again so many material. If the material still has in a good condition, we can reuse it as how it used before. But if it has a bad quality, we can use it for energy, or we can burn it down or make it, like for energy or recycling it. If we're using a reuse material, we can reduce waste, eliminate product energy, reduce carbon footprint, economic value for society, environmental saving plan, reduce waste material, consumability footprint, and also reduce embodied material. And then it's theory that support us in our idea. First, for Peter Graham, the say is the good material is easier to disassemble for the reuse rather than demolish when building reached the end of its service. And also Ken Yang speak about how is good material to reuse is easy to disassemble, reduce the number of different types of material, avoiding using combination of material that are not mutually compatible. Consider how material can be identified. The material is impossible to remove easily and the component that would contaminate the recycling process. That means when we talk about reuse, we can metamorph the building as a material and the Lego. When we can easily remove it and change it with the new one, but we can also use the old one to the another place in another project. Then we have the material that we focus on. What we can see in so many buildings, they have window, door, floor, and also a construction material. In this component, they also have a material that built them. They're like glass, frame, wood, hang, tail, decorative, etc. This item, if we have a good demolish method, we can reuse again, or we can melt it down or disassemble it to make another new one. And then what the kind of parameter that we can see for the material is can reuse again or not. First, they has a simple design layer for IC constructed assembly. Second, they use a fastener that are reversible. That means it can put it out or it can remove it from the material. And then it has no permanent joiner. That means it's no nail on the board or etc. But it use like joiner yang can be removed out the extracted. And then the most important is keep the material pure and whole. That means is if we want to reuse the material, when we want to increase the high presentation to reuse it again, please use manufactured product, or we don't use a unique shape or material kind. Then we have a case study. It's from the Australia housing. The housing has four mainly material. For this material, the study said that has a number of tons of waste. For example, we have a 30-ton timber that actually the material that we can reuse is only 10 tons timber. That means it has 32% of percentage of reuse. In this case, we can see that metal has a higher percentage to reuse again. That's why metal has hardest, it's hard to broken. So we can reuse again in another project. Even it has a bad condition, we can melt it down and build another metal. And then also timber, glass, and concrete is also we can reuse again, but we have good demolish method to increase the percentage of it. And then we have a study case in Dutch that Villa Welepo. 60% of the house is made up from material surveyed from the local area. The supporting structure is made of pattern stars together, primarily used in textile industry and industry that was very important to the region. And then the facade is made of wood from redundant trees. Then when we go to the interior, the floor and the roof were made from the discarded floorboard, also found locally. Inside the house, the bedroom walls are made of compressed coffee cup, which recycled saving the living room. The wood used in the facade was taken from 200 damaged cable reels. That we can imagine how many waste material that been reused in this building. And it's already saved the environment for just single building in there. And then what conclusion that we can think about a reuse benefit is first we can see an environmental, community, and economic. For the environmental benefit, many reuse programs have evolved from local solid waste reduction goals because reuse requires fewer research, less energy, and less labor. Compared to recycling, disposal, or the manufacture of the new product for virgin material. Reuse provides an excellent environmental friendly alternative to other waste management methods because it reduces air, water, and land pollution, limit the new for the natural resources such as timber, petroleum, fiber, and other material. In community benefit, reuse provide new job for people. They can collect the waste material, then sell them to contractors to build a new construction. This will empower the community to be expertise of the waste local material. In economic benefits, when reusing material, instead of creating new product from virgin material, there is less burden on the economic. Reuse is an economical way for people of a socio-economic circle to acquire the item they need in it's less expensive to buy, use, than new, and will cut down the production costs. Maybe that's what I can say for my presentation. Thank you for attention, and sorry if I have some mistake. Thank you.
Okay, thank you. Can this group turn on the camera? Maybe we will have short discussions. Yeah. So this group consists of Reski and then Eki and then Inka. Okay. Professor Mark,
Yes.
do you have any questions or comments? It's still mute, Professor.
Is still mute, Professor?
Okay. Hopefully it's better. One of my thoughts for today is to try to look at the PowerPoint that you did and just kind of talk about that for a minute. And I have a few questions on that, if that's okay. And so, can you pop that back up?
Please.
One of the things I try to do with my students is try to enhance their presentation skills by just giving little pointers on possible things that can help. And it's horrible because my presentations aren't great either. I know they have numerous flaws, but just want to show some of the questions I had.
Can you show the presentation again?
Mm-hmm.
Can you make it screen on again? Okay, let's wait a little bit.
Okay.
For the presentation, actually,
okay, that's
really...
all right. That's fine. That's fine. I made some notes on some of my questions. So on one of the slides, you mentioned roof tile and when it's reused, they had a word barangkal.
Let's Reski, can you show again the presentation? Yeah, okay.
Okay, there we go. Down at the bottom, last one. No, you're fine on that slide. No, go back. Third slide. Okay, at the very bottom. Yes. What is that? What does that mean?
Maybe the other group member will answer.
Hello, I have bad connection. Barangkal is such a material that put down. What usually people say is urugan. Urugan, what is English in urugan?
Urukan.
Like a split stone, maybe.
Yeah,
what?
Maybe.
Aggregate material. A solid material that you put down in the solid soil that will support the entire building on the top
like
of
a foundation, like a foundation. Oh, interesting.
It's about a debris of foundation that has a solid power to support the building on the top.
Okay. All right, go back to the slide. All right. Sorry, it's not a term I was used to. So the section you're currently pointing at, right? I love this information. I was just wondering if maybe it could be presented in a graphical form, right? There's a lot of numbers that you lose the effect, and so a graphical table in which you could sit there and show the comparison, right? In which you could quickly, for bar charts or something like that, I think would have really helped that section. It would have just been, I can quickly spot and say, okay, timber is the major one in case one, these, and so okay, and then go up, and the check marks and X's. Nope, back to that. Okay, in the middle you have the check marks and X's.
Yep.
What do those refer to?
It's referred to if you want to see the material is reusable or not.
Okay. Okay.
For its example for door and window, because some in Indonesia they use nail or they already permanent connection to the hang.
Okay.
Now, if it's not used that, we can use it the component to another project.
Okay. The text on that was a little small, also a little hard to read. So we'll advice on that one.
Okay,
So,
thank you, sir.
Yep. The next slide. This one I love, and so because I like the case study on it. So it actually got me interested. It's like that would have been a really interesting one. The whole compressed coffee cup idea, I have never heard of that before. So I was very curious, finding more information on that. So, but where is this building?
It's building in Dutch in Holland.
Oh, in Holland.
Yep.
Oh, okay. Oh, very interesting.
Based on information we get from the website.
Yep. Excellent. All right. Thank you. I enjoyed the presentation.
Okay.
I'll leave to Patika and
Thank you, Prof. Mark.
Thank you very much, Prof. for the.
Yep. Mm-hmm.
Okay, Pak Toga, please, Pak Toga. Do you have any questions or comments?
No, is this the one that we have already looked over last week? Can you go to the first slide, please?
I think this is the more or less the same material, but they are doing the revisions already after our comments.
Okay.
It's still widescreen, Mas Reski?
It's not me, it's Inka.
Okay, Inka, sorry.
Oh,
It's still blank.
Yep.
Okay, go to the first slide, please. All right, the reuse building material to make a new building. Now, can you go to the questions that you are asking for these specific topics?
The question, sir?
The question, your questions of the topic that you're trying to investigate out. Okay.
What we're trying to investigate is how reusable material could be using in a new building, and then how the construction waste material reduce in renovation project, because we know that renovation project has so many old material that still can be used again.
Yes. For building materials, they are components.
Yep.
They are single materials, let's say for walls, and there are also a combination of materials for the different walls. Now, this combination of materials, are you also taking? Are you going to look also the combination of the materials that can be used, reused, or recycled later on?
On this group discuss, we actually focusing on the material that has a single component. So of that, we say that door, window, floor, and roof. For the material that has a combination component, we what we see in literature that usually say it recyclable. Because if for wall in Indonesia, that the demolish method still has no good effect for the wall. So we only can use that for the recycle, either for the what we say urugan before.
Okay, let's talk about single material like a wall. You know that the wall that we see in every house is that they are not actually one material, isn't it? They have these plastered things. Yeah. Are you going to also talk about that, or just the bricks?
We focusing it on what we're talking is bricks.
Only bricks. Okay, right. Because I think there are some of the materials, a combination of some materials, are quite okay if you look at it as materials which can be reused. Because some of the materials of that combination of material, some cannot be used, but some other can be used. What I mean is that probably we just don't look only at one specific materials if you have a combination of structure or constructions, because these materials actually works when they are built. But if they are separated, maybe they are not, they don't work probably for some reasons, like say the thermal comfort and so on. Yes, that is something that I would like to give an opinion to you. Yes, that's it, Ova.
Okay, thank you.
Thank you very much, Mr. Toga.
Okay. So before I go on to my own questions, do you have any feedbacks from Pak Toga said? You're good?
Good.
No? Okay, then please go again to share screen. Inka, can you do that again? Okay, thank you. I think this group already raised a very interesting topic that we want to building a new building in terms of using the reused material, right? So please go on to the third slide. Here. On the third slides, you mentioned about this data. I'm agree to what Professor Mark said. It's really hard for me to, to follow what you just said, within very short time and to get conclusions out of these tables. You mentioned case study 1, case study 2, and then the percentage of the total waste here and the percentage of being recycled. But then on the fourth slides, please, fourth slides. Again, you mentioned again about interesting case studies here. Like how many buildings we have here? 1 building, 2 buildings?
Single building.
Single building, 1 buildings, yeah?
Yep.
So this one is, what are these?
It's a house, a private house.
No, I mean, what are these pictures from the one in the corner?
Which one? This one?
Yeah, that one.
This one?
Yeah.
It's the steel girders for the structure they use.
Okay, that one for the structures. What I want to hear from you is actually more like tangible things, like when you mentioned about recycled material for new buildings, then you can be sure that out of this recycled material, you already omit or change the new material into this building, Instead of using the new material, you use the recycled materials. And then after that, you will get the impacts like from the society impact, from the budget impact, for the health impact, for example. Then it can be measurable, everything to be comparable among, if you want to have such house, but from the new materials, for example.
I see.
So it's really, you can really have, you can really measure the impact. What are the efforts after you have this building? Okay, then the next slides, please, on the conclusions. This is also what I like. You mentioned about environmental benefit, community benefit, economic benefit, But maybe, in my opinion, these are too general, in fact, you already have these case studies, which is, you know, already the locations, you know, already where to put this building and what are the surroundings. Because when we mention about community benefit, meaning it can be not only for the workers that you mentioned here, but also where are these material come from and what are the typical situation from the current building itself. What are the communities? Are they offices building or are they housing or whatever? Yeah. But in terms of community, they are can be, I think they can be also clustered as well. So I think that's all from my opinion. Yeah, but thank you for the good work. Yay.
Thank you, Ms. Sofa.
Yeah, good. Okay, let's go on to the next presentations, please.
Yes, let me share my screen.
Yeah.
Yeah, good afternoon, everyone. We will give a presentation regarding material recycle, specifically for concrete. Here's the outline. Next, here's the outline from what we will talk about. First is material life cycle, facts about concrete, recycled concrete, and environmental, social, and economic effects. Also, we have this issue. What we will try to answer this question is to how to minimize the construction impacts from material recycling approach, what elements are involved in a material life cycle, what can be done to use materials, especially concrete, as efficiently, what are the recent developments about concrete recycling, and how does recycling material or concrete give effects environmentally, socially, and economically. Next. From this life cycle diagram, we know that a building takes inputs for its constructions and cause impacts from its disposal. And if we zoom in on the making of the material itself, we have another life cycle from its extraction to its disposal, which each stage also consumes energy and produce waste. And this common non-optimal linear process creates a cradle-to-grave system. But there is a better one that performs several actions so the materials can be used efficiently, called cradle-to-cradle system, which close the loop. And this cradle-to-cradle, I mean, I like this refurbish, reuse, recycle, and recover. And on the hierarchy following, those actions are located in the middle between the precaution and the last option because the terms are done when the materials are already used. But actually, we can improve the planning from the beginning by doing a design for this assembly principle, which increases efficiency and reduce next. This design for this assembly principle, which increases efficiency and reduce impacts in removal of buildings and to recover components and materials. Now, if you look on the top of the slide, we have the current condition in the building construction practices, which concrete is one that always emerges. It generates the biggest amount of building-related debris and play a major role for structural elements having the greatest relative contribution of initial embodied impact. So we can see that the urgency to its treatment is high. And considering the DFT principle in the bottom, we need to classify that the materials that it said that we need to classify the materials that are being used to plan the lateral treatment. And if we see the classification here, concrete is in the third category, which is the best to be reprocessed or recycled. So we take on the issue of concrete on which it is recycled. Next. Next. Yeah, this is the issue we have, the recycle and reprocess. Also, if we talk further about concrete, it's known that Portland cement is an important component, and these are some environmental impacts caused primarily by cement production due to air emission, use of waste fuel, and waste as fuel, and the other. And due to its negative effects, there are some ways to make its usage more sustainable, such as by using concrete efficiently and minimizing the EPC's impacts. And in addition, there are many recent studies that we already mentioned the other day regarding the recycled materials and components of concrete approaching sustainability in the right side of the slide. And next. And these are the effect from the recycling materials that we divided into environmental, economic, and social. But mostly we can see that the major effects is on the environmental by recycling the materials. And so it is said by Napolano that construction and demolition waste recycling has the potential to reduce the amount of waste disposed in landfills and to preserve natural resources by avoiding the new material production. This practice has been successfully used in ordinary concrete production. And if we see the effects that here that is written here, we can see that most of them is talking about water, oil, and energy efficiency, and then the less landfill space that is used, and less air pollutants that is released. And also this is from the various materials, newsprint, glass, aluminum, and aggregate and production. Also in the economic effects, it creating jobs and benefits of the economy. Like this is about tax revenue and jobs in manufacturing. Also, the increase of wages. I mean, like the total wages appeared because the jobs is increasing. Also, there are reduction in cost by replacing cement with cementitious additive. It is one of the case here. And also in the social, it creates more employment. Actually, it is kind of similar with the economic, but in the social, we mean like more than to personally than to financially. And human rights, this is no child labor and no discrimination, and this is about child labor mostly. And also it has effects on the economy also because it's related to the job. Next. And this is our conclusion, answering the questions that we said earlier, that the material process takes resources, energy, and has impacts such as waste, but it can be made more efficient if it's done in a closed loop by doing some cradle-to-cradle mechanism. And recycling is the best way to answer the concrete sustainability issues. It also has already been explored for improvement in practice, and it has proven to positively improve social and economy. That's all from our group. Thank you.
Okay. Well then, thank you. Please, Professor Mark. Please turn
Yes.
on the camera for this group.
Excellent presentation. I enjoyed that. My comments now are going to go a little bit different. You know, I thought the presentation, the material presented was good. So not a lot of comments on the PowerPoint. My biggest thing is so the way you present it, it sounds like recycling should be naturally done because it's good. Why isn't it? Why don't they recycle concrete that much? What are the barriers to the process? You see my question?
It is said that in
Please answer.
Yeah.
one of the reason is said in our in the one of our slide, and we said earlier before that the price is relatively high to implement those in Indonesia.
Price is high.
Wasn't it?
But what?
Am I correct?
Well, it's one of the issues, but there's actually some really big things of why it's difficult to do. And so the first one to consider, right, is concrete heavy or light? You know, relative to your materials. It's a very heavy material. It's especially once you formed it on site. And so if I'm going to reuse this on another site, how am I going to get it to the other site? And so the transportation hauling of it is a major problem. And so, and usually you're not going to use it. It's rare that you see like your sample case of you take the actual blocks and reuse the blocks again. Normally what they want to do is they want to crush it. That's very energy intensive to do the whole crushing process. Then you've got to sort out all the rebar, sort out all the materials, then sort it to the next place. And then you can't use it for the same type of thing again, right? Because you've got to evaluate the aggregate. You can't use it as if it was, used as a structural foundation in one place. You can't directly use it as structural foundation in another. And so I think that's my whole point. I would like to see more discussion on the problems, right? And how to resolve that. And so I totally agree with your presentation as far as the benefits to it, but what are the challenges? Because I think that's where we're, as the next generation, you guys need to be focusing on, okay, how do we, these are our problems, what do we need to look at so that everybody sit there and say, well, yeah, of course we recycle concrete, everybody. And so now steel is a classic example. Everybody does recycle steel, right? And so the steel beams, it's a huge recycle rate. So how do we promote that to the other industries? So, okay, that's good.
Any more comments from your group?
No.
No? Sure? No counter feedback? Okay, then let me give the opportunity for Pak Toga. Please, Pak Toga.
Actually, I have also the same question as Professor Mark has just asked. And probably the students have not yet been in the field, so they might not have a better understanding of how this concrete has to be recycled yet. But I just want to give you some examples here. There was, I think, 5 years ago, an old building about 12 or 30, yes, 12 floors high. It was built with wall curtains, but they have this plate or floors with concrete, and they have to, they have to demolish. But the way by which in Indonesia demolish a building, that high buildings, is through crushing by using human energy, and most in Indonesia, or let's say in Jakarta, we tend to ask the Madura. The Madura are a community which they are experts in demolishing, crushing. And when they look at this concrete, they think that because when you want to demolish a building, the client say that you can get all the materials you want. Yeah, you can sell it. That's up to you. So Usually also the clients or the owner would say that how much if you want to demolish this, let's say 30 million and so on. So they get this from materials. Now, most of the materials they take actually are the steel, what we call this, the steel that strengthen the concrete. And as for the concrete itself, they really demolish, and usually as this crushed concrete, they are used to fill some for the, you know, if you want to cut and fill a land, yeah, they sometimes use those also, this crushed concrete, but they take away the steel. And that is also a problem when you use a lot of energy, human energy, to to demolish a 12 floor building, really. And there was a problem actually. This is interesting because one of the a person who crashed, it was a escape stair, I think, fire escape. They they didn't understand that when they have to crush, they cut down the a beam which holds the other structure up there. And when they cut the beam, the building falls, and he died because of that. Yeah, this is a very a serious problem actually, when you want to demolish a building, especially concrete in Jakarta. So that is also a problem for human safety when you want to use the materials. That's all I can add. Yeah. Okay.
Okay, thank you, Prof. Mark and also Pak Toga. I think both of you also addressing a very important issues about the material itself, about the concrete, and the important things of having prior knowledge of what it is, what are the materials. There are also one story about this ethnic, about the Madura ethnic. They can also do this kind of things, even though the material is located deep down in the sea. Like for example, if you have like a ship that's already collapsed and then going to the sea, they can do that. They can do that easily.
Yes.
Yeah.
Yeah.
It's very specialties of them. Okay, let me go back again to your slide, please. Can you also share it again? Thank you. Back to the first slide, please. The title one, please. The title page. Is it the title page? Okay, one more ahead. Okay, then, yeah, this one. I think when you mentioned about recycling materials and then you mentioned about concrete, then Professor Mark and also Patoga will be asking why you choose concrete instead of the other materials. That would be my first questions. But however, you already raised a very important message that you thought that one of the ways to decrease the environmental impact is to use them minimally, right? That's very good. And if I have to point out my questions, first you put out the title for your group, recycling material and concrete, and then go on to the next slide, please. Okay, this is very good. You mentioned several questions. Yeah, the main questions is how to minimize the construction impacts from material recycling approach. Yeah, and after these big questions, you have also have sub questions. What are the elements involved? What can be done? What are the reasons, development? How does recycling materials and so on and so forth? But again, the big questions is how to minimize the construction's impact from material recycling approach. That would be your questions. Then we go on to the conclusion, please. Okay, we stop right here. So the conclusion tells us about the material process, tech resources. Sorry, I cannot read them in the full screen. Can we just stop the, how to say, share screen? No. We just go back. You don't need to have it full screen. Can we? I missed something here in the left side. Yeah, and then please click again on the side 6. Okay, it's okay. I think I can read it. So for the questions that you raise, how to minimize the construction impact from material recycling approach, you have answered that the material process takes resources and energy and has impacts such as waste, but it can be made from efficient if done in a closed loop by doing some cradle-to-cradle mechanism. Okay, then if I repeat again your questions, how to minimize the construction impacts from material recycling approach, one of the ways is by doing some cradle-to-cradle mechanism. Okay, that's one point. And then continue to the next one. Recycling is the best way to answer the concrete sustainability issues. It also has already been explored for improvement in practice, and it has proven to positively affect the environment, social, and economy, which means all of these conclusions, yeah, regarding your questions, you have only one left sentence that is answering your own questions, which is you mentioned doing some cradle to cradle mechanism. So out of these long explanations, you end up with this very short presentation, short conclusion, doing some cradle to cradle mechanisms. I'm still wondering if you can structure again your conclusions, because however, we will refer to your questions, how to minimize the construction impacts from material recycling impact. Can you repeat that again in your own questions, in your own answer about this, the conclusion, please? You can stop share screen.
Maybe I want to answer. What we mean by the conclusion is like we answer the sub question, but we missed that. I think we missed that those answers are not are not referred to the main questions. Yeah, we missed all that. So to answer the main question, how to minimize the construction impacts from material recycling approach is we actually this conclude in our presentation. Like, so we first is we have to see the what is we have to see it as a whole system, and then we see what we can do, and then we do it. So we get the effects, like, yeah, actually like that. So we have to see it as a whole system. Do you mean the exact action to minimize the impact, or
I'm just referring to your questions. That's all. Your question is how to minimize the construction impacts from material recycling approach. So by that questions, meaning I will get the answers that how to do that, right? Yeah, and this is what I want to know because I couldn't find it in your conclusion.
or
The other
maybe
member?
maybe the question is like more like how to minimize the construction's impacts by recycling the materials. No.
The other group member will like to help maybe. Juliana and Hafiz, what about it? Okay, okay, we can skip these questions. But I'm still wondering why your group choose concrete instead of the other material. Like steel, maybe it's easier, or maybe it's more familiar in recycling activities.
It is on the the second slide. Actually, that we see that the concrete is the most impactful material. That it is used massively, other than the other materials, and we if actually we just the first is like we just recycle one, and so we search like what are the material that is more suitable to be recycled, and we see the existing case like concrete is used massively, and so we match it. So yeah.
Okay. To understand your point is actually you are seeing to the material which has bigger impact, right? So instead of choosing like material which is already being recycled everywhere, you choose the material that is actually brought a lot of impact for the environment, which is very good actually. It's a good approach. Okay, I think that's all from mine. Yeah, thank you so much. Yes. Okay, thank you. Very good. Okay, then we can continue to the last presenters. Yeah. Okay, so Prof. Mark, what about it, Prof. Mark? Your time is up actually, but we still have one more group. Is it okay to continue?
I'm fine. Oh, definitely.
Okay,
Yes.
thank you so much. Thank you. Please continue.
Okay. Thank you, Prof. Mark. Thank you, Patoga, and thank you, Bova. I will share my screen. Okay, let me start. Good evening, Prof. Mark, and good afternoon, Pak Toga, Bu Ova, and friends. Today, I would like to present our presentation entitled Eco-Effectiveness and Eco-Efficiency Materials for Building Envelopes with Precast Fabricated System in Jakarta, Indonesia. Nowadays, the development of technology stimulates the building's construction duration as well as the green materials. Thus, the study aims to acknowledge the precast fabricated system which applies in the building envelope to gain the eco-effectiveness and eco-efficiency materials for mid to high-rise building in Jakarta, Indonesia. Also, the question is how the precast fabricated materials for the building envelope to manage the effectiveness and efficiency which influence the quality of life in Jakarta, Indonesia. Also, we have the parameter for selecting building materials. Our first emphasis on reducing the number of materials needed for construction. Second, reuse materials and products from existing buildings. Lastly, we use products and materials with recycled content or made from renewable resources. Here's the synthesis diagram. The Earth provides spaces for sustainable development to respond to the ecosystem. Furthermore, there are several goals of construction materials and industry in sustainable development, such as renewable resources and fuels, reuse and recycling, and impasses the life cycle cost, waste, emission, and pollution. Thus, to lengthen the life of ecosystem on Earth, it uses cradle to grave, which produce the biological nutrients and the technical nutrients. There are also several ways to support the cradle to grave in terms of facing industrial improvement these days. One of the ways is by using green materials for building envelopes. Also, the building envelope has three elements such as the wall, window, and the roof elements. Moreover, to make the building envelope more efficient by using green materials with precast fabricated system, especially is suitable to applicate in urban contexts. The green material also could affect the indoor environmental factors in terms of influence human health, as well as have the mutual support between the life of ecosystem and living creatures themselves. On the other hand, it would be more effective when the material industry are located nearby, and then reducing the ecological footprint to respond to the environment, social, and economy around that context. Some of the manufactured materials have a high hemodynamic energy and carbon, but by using fabricated system, it could help the efficiency, energy, and also the carbon. Therefore, there are some strategies to gain the eco-effectiveness and eco-efficiency materials in building envelope with a less ecological footprint that would support the sustainable development to elongate the life of ecosystem on Earth. Here is the elements of building envelope material, which usually found around Jakarta. For wall elements, it is precast concrete, brick, lightweight concrete, metal. For windows elements such as aluminum, glass, UPVC. For roof elements such as metal, UPVC, glass roof, concrete, roof tile. And here's the comparison between the green materials and the regular materials. The green material with precast fabricated system consists of precast fabricated concrete, UPVC, glasses, and the regular materials without precast fabricated system, such as brick, lightweight concrete, metal, aluminum, metal roof, roof tile. And as is on the screen, the embodied energy that could affect the carbon itself based on the color in the screen. Okay. Here's the indoor environmental factors. The building envelope with the elements of wall, window, and roof integrated with the passive design strategy, which consists of geometry, insulation, fenestration, doors, air leakage, ventilation, thermal mass, shading, and color. The passive design strategy could control the physical factors such as the sound or noise, transmission, lighting quality, thermal condition, and odors, which improve the comfort of the occupants. And here's the effect of materials on human health. There are several effects, bad effect and a good effect. The bad effect from the bad material manufacturing causes pollutant, and the bad and it causes unhealthy life. Also, the bad material manufacturing causes various diseases. And then good effect from material manufacturing causes a healthy life. And here, the sustainable strategy design to minimize embodied energy and carbon. First, use locally resources material. Second, durable, low maintenance material. Third, modify or rebridge materials. Fourth, reuse or recycle construction waste and materials. Fifth, avoid wasteful material use. Sixth, designing as needed. Seventh, use efficient building envelope design. And the conclusion, first of all, we must consider the site, especially the accessibility, efficiency, and effectiveness of material application. As we consider in urban or crowded area, it is hard to find pure natural materials. Therefore, considering the concrete, UPVC, glass, and many more are important as a man-made material. It is could help to reduce the amount of material use. Even though some of them have high embodied energy and carbon, but in other aspect with the precast fabricated system. In addition, the usage of material must be recycled, used, and have a contribution to the indoor and outdoor environment. Also improve the quality of life for humans and other livings for physical and mental health, saving the time for construction more than conventional. Lastly, it is accessible to reach the factory and the products in urban area. That's all from us. Thank you.
Okay, Thank you. Great presentations. Please, Prof. Mark.
Oh, excellent. Very nice presentation. So I enjoyed that. One of the things as a general thing for the audience, and one of the things I do with my students for group presentations is I have them watch a little video. It's a little comical video where it's one engineer goes through and talks about, it's called Death by PowerPoint. And he points out common errors that people make when doing PowerPoint presentations. He's got a little short version about 4 minutes. He's got a longer one about 9 minutes. And I recommend watch that. It's enjoyable to watch. The person's name is Don McMillan. And if you do a YouTube search, you'll find that. And you'll see some general things that he points out. One of his things that he's a pet peeve that doesn't like is if you put exactly what you're saying on your slides and then just basically read your slides. So you want to watch doing that as much as you can. One of the nice things about Zoom is you can do your notes on the side, right? So you can read your notes and not have to read the actual slide. But anyway, I encourage you to watch that. So let's go to slide 3. Sorry, that's 2. One more.
Here?
Okay, yep. Under regular materials without precast fabricated system, what are those sorted based upon? The brick, lightweight concrete, metal, aluminum, metal roof, roof tile. What are those sorted based upon? Why did you pick that order?
Okay, thank you for the question, Prof. I will try to answer it. We choose these kind of materials because of it usually found in Jakarta.
I understand that, but why did you go brick first, then lightweight concrete, then metal, then aluminum? Why that order?
Are you, did you mean that
The first one you show is brick, right?
Yeah.
After brick, the next one is lightweight concrete, right? So I go from a green thing to a pink one, to a blue one, back to a green, then to a blue, then to a green.
Sorry.
Why? That's okay. Hope you're going to get my point here in just a minute to be like, oh. So why did you do it that way? Why did you go brick as your first one, lightweight concrete as your next one? So order you thought about it?
Honestly,
that's okay. That's what most people do.
we just try to put the materials on it, and we maybe didn't even notice or consider that kind of thing.
That's actually my point. Is you have the right, when any type of graphics, any charts, any documentation, and do this for any of your presentations, right? When you order the things, order them in a way that it in itself is a message. So in this one, it'd been nice if you started, maybe done all, see, I liked in your top one, right? The one above it, you go pink, blue, green. It's wonderful, right? Your one on the bottom one, the body and energy, you go pink, blue, green, okay? So your regular materials, order them, right? Do pink, blue, green, right? And so it all follows consistent. Okay. It's kind of a thing that I try to teach my students also. Whenever you do any type of graphics, you can put the things in whatever order you want, right? And so try to do it in such a way that the order spells out a clear message along with that. So.
Okay. Thank you, sir.
Last one I got is go to the one slide where you talk about the good health effects of the building. Yep,
here
there you go. Yep. So how am I improving my human health by these materials? So I got bad human effects. How
Yeah.
are these good human health effects?
You mean like how the effect from the materials that could improve the healthy life, isn't it?
Yeah, how does it make you healthier to have these elements?
I think it's because of the passive design strategy that try to applies in some buildings because
I can.
yeah.
I think. Sorry, I think you're missing this one still. And so, all right. So because of using certain materials, I can get cancer. Right. I can. The bad ones are very clear. The health effects are very obvious. Right. The bad health effects is cancer, breathing, respiration. You spell it out wonderfully. Right. So now you tell me I've got good effects. I've got good health I can get out of my building. Right? This is under the human health. And so what material is going to make me healthier that I'm putting into the building?
Maybe I think all materials kind of good things, but it depends on the function of the materials. I think, yeah.
Your good effects. It's good effects, but it's not good human health effects. Is my point. And so, what you want to watch the labeling on that. And so, you know, there aren't a whole lot of materials that I can think of that are going to make me healthier. I can be less unhealthy, right? But so maybe just want to watch the heading on that one and how to label it a little different. So that's all I have. All right, thank you. I thought it was a good presentation.
Okay, thank you, Prof.
Yep, thank you.
Thank you, Prof. Mark. Anyone wants to have another opinion maybe instead of Natasha? Maybe Mas Masyuri or Fiska, do you want to give some feedback? By the way, please turn on your camera.
Okay.
Okay. Have you?
Wait a minute. Okay.
Do you have any other comments regarding what Prof. Mark said? I think Prof. Mark already raised a very important issues as well regarding selecting the materials, regarding positioning them. Once you have your own order, meaning you need to be consistently using that kind of order, because this is what the way we saw and we understood, and we want to have like repetitions. Also about the good effect doesn't really mean like a good health effect for the human being, right? Okay. Should we continue to what Pak Toga session now? Is it okay? Yeah. Okay, Pak Toga, please, Pak Toga. The mic, Pak Toga.
Let's go back to the first slide, please.
Okay.
All right, here, hold on. Go back again to the first, yes. This is, I think, the question that have been asked last week, yeah. You have that eco-effectiveness and eco-efficiency. I think you also have to put your descriptions on how do you measure effectiveness and efficiency. I think that is important because you already have these topics, the eco-effectiveness and eco-efficiency. So using this word, then I hope in the conclusions later on, after your studies, that you have some measure by which this material is not effective, that material is not efficiency, and so on. So I think you need to, my comment is you need to also use what kind of measure are you going to use that, all right? That's it, Bu Ova.
Thank you, Pak Toga. Please.
Okay, thank you, Pak Toga, for the comment. Yeah, may I ask, Pak Toga?
Yeah.
What kind of measure that you state before? It's like just the parameter for selecting building materials, or like the amount or something like that.
Okay, when you say effectiveness, what do you mean by that? How can you say this is effective and that's not effective? You must have some basis by which you can say that because of this, that is not effective. Okay, that's what you have to present your own measure device or tools, yeah, by which you can measure. Yeah.
Okay, thank you, Pak Toga, for the comment and explanation.
Okay, no answer from your group? No answer? Like countering what Pak Toga mentioned? Do you have actually?
We just have the parameter for selecting building materials, and about the tools, maybe we must try to elaborate all of the components tools that we could make the tools for, I think, like rating for the efficiency or effectiveness materials. Is it like that, sir?
Yes, of course. What I mean is that if you let's say this an easy thing, okay? If you have to bring the materials, very specific materials that you can't find locally, you have to bring it to the site by which you want to build. And then you also have a large community that can also make that kind of materials, which probably not very good, but it is usable. You decided which is much more effective using a material that is quite far, and then you have the community that you can use the product that they made, okay? Because that also comes to terms with the quality by the community that made, and you know the other you have to bring from, let's say, imported materials. And then you know that because of its distance, then having a good material, a much better material, is not effective, because you can have you know, not really a good material, but they are also green, okay? So you make that you make that measure, all right? All right, that's I give you a glimpse of what I mean by a base by which you can say efficiency and effectiveness. Let's say if you have a lot of let's say if you want to make a construction probably 100 square meters, and then you have to bring a lot of the source of the materials that you use for the buildings, for 100 meters walls, okay? you use materials which probably you have probably 3 tons, but then you only you can only make with the 3 tons of brick, let's say a brick, then you can have only 100 meters square. That's not efficient. Okay, that's what I mean. All right.
Oh, okay. Like a mapping, like a mapping for the context and it's manufactured.
Yeah, let's say if a wall, we know that the wall here in Jakarta are made by bricks and concrete. All right. But do you have also an understanding that bricks and walls, we can use another kind of materials that we can make walls, all right? Probably with woods or triplex and so on, okay? With your goals that it has to be green, and then it should be able to make comfort, thermal comfort inside, rather than you have to use bricks and concrete, let's say, then you look at that, which is much more efficient, effective. All right, and that's what I want to you to also put in your research, yes, presentations, that you need to measure this. Okay.
Okay, thank you, Patoga, for the explanation.
Okay.
It's very helpful.
Okay, but I would like to hear from Mas Yuri or Rizka. Do you have any other comments to counter? The mic, please. The mic, Mas Yuri.
Okay, ya, baik, Ms. Ova and Mr. Toga. I want to explain that this we choose the precast is for mid high-rise building. Yeah, this is my concern in discussion. So I mean that this is effective for in Jakarta area, because we know that Jakarta is very crowded, and I think that with precast it's more efficient than another. But in this my presentation, I know that we have the measurement to describe that this one is more effective than another, or this is efficient the material with another. This is maybe we must to explore more. Thank you, Mr. Toga.
Yeah, because I think you are an architect, Mas Yuri. You have been doing some, building constructions. I believe that, yeah. And in many years before, the lots of building here in Jakarta use steel as the main structure. They use really concretes. And most of the constructions engineer here says that it's much better to use concrete because it's much more effective in terms of its economic, and it is also already local resource. Still was very difficult to get in the past 20 years ago. Yeah, so they use a lot of bricks, concrete, and that become a tradition. Which maybe you now in this let's say in this time, that probably that is really not effective or even efficient. Yeah.
Right. Thank you, Mr. Toga. Yes, thank you.
Okay.
Okay, thank you. I think we have quite tough discussion for this group. Yeah, let me continue then. Thank you, Patoga and Prof. Mark. Actually, Prof. Mark and Patoga knows, but actually, Prof. Mark, the main task for this assignment is actually we have questions, what we need to consider to select sustainable materials. That's the main questions for this task. And then each group needs to develop what are the materials they want to highlight, and then what aspect that we need to consider. Yeah. Okay, among those three groups, I think this group has quite complete ways of analysis. Yeah, starting from like showing the outlines of the presentation. Yeah, the other groups also did that. Having one questions to raise, and also having definitions about eco-effectivity and eco-efficient materials. And here we have the parameters for selecting building materials. This is actually the main questions from Patoga. Okay, having parameters to analyze something is one thing, yeah. But how you gonna use these parameters is one thing. Meaning, if you want to use the parameters, for example, use products and materials with recycled content or made from renewable resources. So, what are these parameters used for, or what are these parameters will inform you for your analysis? Will it be good or will it be bad? If it's good, for example, how much is actually the range? Yeah, okay, using project materials, maybe they only use like 10%, or maybe they use 50%, or maybe they use all of them, for example. Then which are your status? Yeah, this is about using the parameters. I think it's already being discussed with Patoga itself. Okay, so next slides, please. Yeah, okay. This is the things that I really like from your group. You are doing this synthesis of paragraph, meaning you have collect a lot of theories and also from different sources to, how to say, to help you in finding your own answer from your questions, right? Here you develop some groups, yeah, where you put the emphasis of embodied energy and carbon and also ecological footprint, and you combine them, one of them, you combine each other, yeah. You put a lot of sources, Yates, Castro, Sassi, Chalkins, and so on and so forth. This is very good, actually. You need to consist more work on this kind of theory and this kind of method. But again, please go on to the next slide. Yeah, for this slide, I don't really see any connections to your synthesis. Meaning, I don't really see that your synthesis help you a lot in providing the next steps. Yeah, here you put the architect and you put also one other sources here. Yeah, and also go to the next slide, please. Yes. Here again, another, how to say, general idea. Yeah, in fact, if you have a lot of information, I mean, if you already read, you know already a lot of knowledge, you gain a lot of knowledge from your previous synthesis, meaning you can already spread the new information with your own language, which should be very rich. Yeah. Here you mentioned about bad effect and good effect, but it doesn't really connect to what is effectivity, what is effectiveness, and what is efficiency. Again, back to your own questions in the beginning. And here you didn't really show us that you already developed or gained the information, sort of information from what you have read before. Yeah, I think so. I think so. About my comment. Do you have any comments from this one? No comment, Mas Yuri, Natasha, or Fiska?
Thank you, Bova, for the comment. Yeah. In the future, we
explore again.
We have to,
We have to explore again about this.
yeah, and connect between each of the topic here.
Yeah, I think if you go to the groceries, yeah, you already bought a lot of things. Yeah, but in the end, after you got home, you forgot what do you want to cook.
I see.
Yeah, but
Yeah,
however,
thank you.
I would like to appreciate your group. Yeah, the way you structure your presentation, the way you collect all of the information and you make it step by step, it's actually very good. Actually, yeah. What you need to do is to use what you have, yeah, for your next stages, and then back again in the last stages, you back again to your first questions. Actually, what is your aim in the beginning? What do you want to find out? Yeah, okay, you want to go to the precast, right? And you talk about efficiency and also effectiveness. So what are these triangle told you about? Yeah, after you bought a lot of things in the groceries. Yeah. Okay, but well done for this presentation. Yeah.
Thank you.
So it's like we try to straightforward to our topic. Is it like that?
Of course.
Okay.
Of course, you need to answer what you raise. You need to answer what's your questions because that's the goal, right?
Yeah,
otherwise,
right.
what you need to do to have these questions if in the end you didn't answer it correctly? Yeah. Okay. Should I applause now? I already did already.
Okay. Thank you, Bova, Patoga, and also Prof. Mark for the comment and
thank you for this group. Please stop share screen because I would like to see you all. Yeah, okay. Please turn on the camera now, all of you. Okay, so Prof. Mark, actually, each modules that we are now in the second module, the material and construction module. Yeah, in this module, we normally spend like 4 weeks. Yeah, the first 2 weeks, we only talking about theories and case studies that we have all around the world. Yeah, including Indonesia for sure. The next 2 weeks, we will be in charge with the real building, which is our case studies, and we already selected one building in our university. It's quite new building, yeah, but we define all of the things from that building in terms of material constructions, and also the next module we will talk about wastewater and the drinking water on that building itself. So I think for these 2 weeks you already accompanied us in perfectly, yeah. I would like to say many thanks for that, and I also consider that your time is not really suitable for us, but you still commit to to have your lecture with us for these 6 lectures. Thank you so much. Okay, maybe you would like to say something for this class, or maybe the students would like to have something for you.
I have greatly enjoyed working with all of you. You're very engaged, very enthusiastic, and I look forward to writing to you in the future. Uova obviously has my email address. If you have any questions, you want to stay in touch with me, feel free to send me an email. I look forward to working with you in the future, and I look forward to continuing the series, working with you, Uova and Pataga. Hopefully in the future we can do this in person as opposed to Zoom.
Yes.
In person, I can get a little bit more sleep before I present, and so a little more engaged. My final point to all of you, the students, is you're the change. You are going to be the ones that drive the future, and so I hope that we can pass on this passion of a emphasis for sustainability, and get involved, join the applicable organizations, get involved in Indonesia, and make those changes. It takes time, but you got to start somewhere, and you are the ones that can see that happen. And so I look forward to seeing that transition. And so I've greatly enjoyed it. Thank you very much.
Thank you. Thank you.
Thank you, Prof. Mark. Is there any words from the students? Maybe one or two students, please. Turn on the mic before you mention something.
Ma'am?
Anyone? Natasha, you want to say something? Or Inka?
Hello, ma'am.
Or Anin?
Oh, suaranya jelek.
Reski, Bu.
It's okay, Reski. It's okay. I can hear you.
Oh, okay. What I want to say is thanks a lot for Professor Mark Russel that's been give us so many knowledge that we don't know before, and then give a new insight for a sustainable development that a little bit different between America and Indonesia in here.
Yes.
It's also make a new experience that we may know that how American have their standard and Indonesia have their standard, but it can be compared between its two because it has different region or different external point that everything is different here, but we have a same way to prove that human can be grow with the environment also. And before we build something that we must think about everything that connected with the building. So thank you very much for the knowledge that we don't know before, and maybe we can discuss in offline situation or in some place we can meet.
Yep, definitely.
Thank you.
Yep, thank you.
Thank you, Reski. One more students, maybe, before Professor Mark go back to sleep. Anyone? Juliana or Anin? You want to say something?
We are shy people.
That's
Professor.
fine. No, that's not a problem. So if you're ever in Florida, be sure to look me up.
Me, no,
happy to show you
not
around.
yet. Yes, yes. Also, if you come to Indonesia, I think we have to take Professor Mark to outside Jakarta, not only in Jakarta. Yes.
When I was there a year ago, I got to go to Bali, which was wonderful. And so it was
Bali,
looking forward to
yes.
coming back.
Yeah, of course.
But I
Bali.
like Jakarta also. Yeah.
Juliana, you want to say something? It seems like you want to say something, Juliana. Go ahead, it's okay.
When are you going to go to Florida to further your study? You can ask Professor.
Okay.
Yeah.
Maybe I want to give thanks for Professor for the knowledge. And I hope we can meet in Indonesia soon.
I hope that too.
Or in Florida. We can meet in
yes.
Florida.
I mean,
Or in Florida.
Yes.
We have a lot of scholarship programs available here at University of Florida, and so my slight advertisement is our graduate students are almost all international students. So
yes,
good information, Professor Mark. But
Yep,
they are just in the first semester. I bet that they need to spend another 3 semesters to get that
Yep.
scholarship. I hope so that they can finish everything
Yes.
in well.
Yes,
Yep.
yes.
Okay, Patoga, you want to say something, Patoga?
No, because tomorrow I will also see the students, so there's nothing to say anything else.
To Prof. Mark, maybe?
Oh, to Professor Mark, yes, of course. Professor, we wait you to come back here to Jakarta, and I'll take you to Flores, the place where I do research there. It's not like well, it's another kind of Bali, but let's say if you imagine Flores is about 20 years Bali at this time.
Wow.
Okay. So Bali should become so many people come there. It's become developed, but Flores is like 20 years of Bali at that time. Yeah.
Well, I look forward to that.
Yeah.
I'll take you up on that. Thank you.
Okay.
Or maybe we can arrange like a group tour.
Yes,
All of
yes, of course,
students.
of
That'd be
course.
wonderful.
Of
Let's
course,
see.
and you will see a lot of bamboo. Oh, very beautiful bamboo. Yes, we talk
Big
about this
size,
bamboo. Yeah,
not
big
only
size,
big
small
size, but
size. Yes,
20
really,
centimeters like.
really, yes.
Wonderful.
Okay, then
right.
Prof. Mark, on behalf of the university, also our Department of Architecture, Faculty of Engineering, also from our head of department for sure, Bapak Dalhar Susanto, we would like to say thank you so much, for your participations, for all of your contributions as well. I suppose that you are not only giving, but you also took something from what the students' presentations, for example.
Oh, very much so.
Yeah, because we would like to have this kind of sharing things, not only because of the pandemic, but this is the way we should be, I think. Yeah.
Yes.
And hopefully we can do that. We can do this again.
Yep.
Not only virtually, but we can do that physically.
Yes.
So please, we are most welcome for your visit next future to Indonesia. And as Fatoga said, we will go to Flores.
I look forward to it. Thank you. Thank you all.
Inshallah. Okay, then. Okay, then, everybody,
Right.
thank you so much for this
Bye.
presentation.
Stay healthy.
Stay healthy.
Yes.
Yeah. Bye-bye.
Bye-bye.
Assalamualaikum warahmatullahi wabarakatuh. Selamat siang.
Siang.